Your data is growing faster and is more complex than ever, and that makes it challenging to plan and manage data storage. Now developers and IT teams can stop worrying about predicting data growth. Instead, focus on growing your business with Microsoft Azure Storage, a massively scalable, highly available, and secure cloud storage solution from Microsoft. Azure automatically makes multiple copies, so your data is always safe. Once your data is in Azure Storage, you can easily access and manage it using familiar developer APIs and Azure Portal. And the best part? Azure Storage is pay-as-you-go, so you only pay for what you use. Microsoft Azure Storage offers Blob storage, standard disk storage, premium disk storage for high IOPS workloads, file storage for fully managed file share, table storage, and queue storage. You can easily extend on-premises storage to Azure using Store Simple, back up your data using Azure Backup, and protect your applications against disasters using Azure Site Recovery. With Azure, it's easy to move your data in and out of the cloud. You can use ExpressRoute for high-speed connections, or use the import-export service and send us hard drives. Azure Storage is integrated with a number of partners, so there's always a solution to fit your needs. Data growth doesn't have to be a headache for you and your business. Solve your problems by using Microsoft Azure Storage. Sign up for a free trial today.
I'll be presenting Azure Storage today. We're going to begin with a quick introduction. This is going to just cover some basics of what Azure Storage is, how you can use it, in what scenarios you can use it to reduce your own COGS, as such, your operational costs. In addition, we will just go through the various abstractions that we provide in Azure Storage for your consumption. So what's cloud storage? It is a storage in the cloud that provides you anywhere, anytime access. The caveat being as long as you have internet connection, obviously. It provides you blobs, tables, disks, and queues as abstraction. It's highly durable, available, and massively scalable system. It's durable because we retain multiple copies of your data. So when you send us a request, we actually make it persistent on multiple nodes and then return success to you. It's highly available because of the way these copies are maintained within our data centers. And it's massively scalable because we use range-based partitioning scheme. So we understand your traffic pattern that comes to us, and with that, we auto-load balance these partitions so that we can meet your traffic needs. All this allows you to build internet-level scale applications very so easily on top of Azure Storage. And the proof being that we do more than 25 trillion, we have more than 25 trillion stored objects, and we do more than 2.5 million requests per second on an average in Azure Storage. What's cool about this is it's pay for what you use. So there's no upfront cost of planning, saying you need to store 300 terabytes of data over the next 2 years, so I need to plan for my data center or anything of that sort, or maybe even petabytes of data. It's pay for what you use. So as you grow slowly, that's how you would be charged. It's exposed via easy-to-use REST interfaces. So there are REST APIs. And for those who are used to using client libraries, we have client libraries in various languages. Cloud is truly language agnostic. So we have a lot of languages like C++, Java, Android, .NET, Node.js. So quite a few libraries out there which you can start using. In addition, there are value-add tools like which enables you to copy your data from on-prem to storage and vice versa. And so all these things is what Azure Storage kind of exposes to help you build internet-scale cloud applications very easily. By far, it is the most number of regions that any major cloud provider has. So, this is something which, again, enables you to build your cloud storage applications based on where your consumers are. Double-clicking into the abstractions that we spoke about, Blobs provide you a massively scalable object store, basically for your unstructured data as such. So you can store your files or what you have on your on-prem logs and things like that into the cloud. It provides you a simple REST interface for putting, getting, deleting blobs, listing your blobs, and things like that. In terms of scenarios that it helps you build, there's data sharing scenarios where you can share documents either with everyone, making your container public, or with a subset of folks by using authentication modes like shared access signature. In addition, you have the big data scenario. All of us have tremendous amount of logs that we have for our own applications. That's true for any application. All these logs can now be analyzed in the cloud by keeping it in storage and then using whatever your favorite MapReduce job is to go and analyze these logs and get important data out of these logs to improve your service or your application. Backups is another common scenario where many people have written backups to the cloud. So they back up your phones or your important data, on-prem data, into the cloud so that you can retrieve it anytime you've lost a device. In addition, people have built sync services. So you want to back up from one, maybe back up your images and make it available on another device. So all these scenarios are possible through Blobs. These are network-mounted VHDs in the cloud, and these are basically stored as what we call as page blobs in our Azure Storage blob Azure Storage blob abstraction. They are fixed format VHDs, and in the cloud, in any one of those virtual machines, now you can go and attach this blob as a VHD. So you get a disk where now your on-prem applications that were used to writing to a disk can easily now write to disk in the cloud, which is made persistent. Tables is a NoSQL store which massively scales. So again, all the abstractions out here which we've spoken about, it scales because we learn from your traffic pattern and then load balance it. So tables is a very similar abstraction. It's a NoSQL key lookup NoSQL store. And some of the scenarios that it enables is, for example, maybe your website has users and you have user profiles. So you can easily store these so that when a user logs in, you can either validate, authenticate the user by storing their passwords in Azure Table or by storing their profiles in Azure Table. We also have OData protocol. So Azure Tables is basically following the OData protocol, and you have JSON or AtomPub. We recommend JSON just because of the amount of data savings it has. It's almost 75% data savings over AtomPub. But you have these two protocols that you can easily follow, use for your applications, rather. Queues is a reliable messaging system. So when you build a scalable application, your scalable architecture, there are many components that need to communicate with each other. The recommended way to make them scale is scale them independently so that one failure in one component does not back up another. So you need a messaging system when they try to communicate with each other, and Queue provides this reliable messaging system with low latency and high throughput. So you can, like I said, you can decouple your web role from your worker roles now so that they can communicate each other, and failures in one would not back up the other. People have also built asynchronous task scheduling as such. So you want to start a job in, let's say, in 2 days, you can put in a message that is visible in 2 days. Or even building process flows or workflows using these queues to kind of orchestrate the process flow. We have other additional value-add services and tools. Azure Import Export being one of those, where you can easily move terabytes of data from Azure Blob Service to, or from your Azure Blob Service rather, to your on-prem. So you can ship the disk, and these disks are all encrypted with BitLocker. So you can ship the disk, you can store your data, encrypt the disk with BitLocker, and then ship the disk to our data center, and we will import that data into our storage. So if you have this is very valuable, especially in places where you do not have great connectivity between your on-premise to Azure Storage data centers. With respect to tools and libraries, we spoke about quite a few client libraries that we have in Java, .NET, C++, Node.js, including Windows Phone and Windows Runtime. There are PowerShell commands for many folks out there who are more used to PowerShell. They can do their more administrative workflow as such using PowerShell commands. There are CLI tools for those who are not on the Windows platform. This is all Node.js related stuff, so you can go to any platform that you work on and still kind of manage Azure Storage from that particular platform. We also have a tool called AZ Copy, which enables copying of, again, data between your on-prem to storage. This assumes that you have good connectivity. In addition, AZ Copy also allows you to copy data between storage accounts. So it's kind of like a backup. So you can do that too. So AZ Copy is there for Blobs today, and we will have it for tables later this year. So we spoke about Azure Storage and all its tools and libraries that are there today that enables you to communicate with it. Now getting to what kind of durability it provides, there's one durability in particular that we want to talk about out here. And again, we will double click into the rest of the durability provided by Azure Storage in a bit. But Geo Redundant Storage is something where you can enable for your storage accounts. And if you have enabled it, what it does is it provides redundancy for your data across regions, and these regions are at least 100+ miles apart. It's provided for blobs, tables, and queues, basically our abstractions today that we have. You choose a primary region while creating a storage account. When you choose a primary region, the secondary region is assigned to it. So it is not user control, but these regions are kind of paired. So if you create a storage account in US West, your secondary region will be in US East. So once you have set up geo-replication, the thing to note out here, and a very common question is, how does it impact my live traffic? It does not impact your live traffic because this is done asynchronously. So it's off the critical path. We replicate your data multiple times within the same region. In addition, asynchronously, we replicate your data to a different region here. The thing that we announced at Build was general availability for RA-GRS, that is read-only access to your replicated data. What this provides is a scenario for you to get higher availability if your primary region is down for whatever reason. So when you try to access your data in your primary region and you get some sort of failure, a 500 error, for example, you can now go to the secondary and read that data. Applications need to be aware that this is eventual consistency. In addition, we have provided a way for you to get the last sync time for your geo-replicated data, so you know that you're getting the data, all the data before that has been kind of committed and available to you. So that we give you a timestamp, and again, I'll show you a demo at the end, how this can help in building applications for higher availability. So how it works, you have GRS enabled. You get a secondary endpoint once your GRS is enabled as such. Or rather, once you go and opt in the portal for RA-GRS. And again, I'll go to the portal and show how you can configure it. So once you enable RA-GRS, you get the secondary endpoint. So now you have two endpoints. One that points to the primary, which is called account name blob table queue.co.windows.net. And then you have your secondary endpoint, which is account name -secondary. So now you have these two endpoints, and you can now choose where you want to send your request based on whether it's obviously all writes have to go to the primary, but your reads can either go to the primary or secondary. If your primary is unavailable, you can dispatch it to the secondary, basically. So applications control this, and in addition, storage client libraries have a knob for you to set this so that it automatically goes between the primary. If it fails, it'll go to the secondary. So you have a lot of these retry options out there which says primary only or secondary only, or primary then secondary. So you have these options that you can set out there to choose the right location or choose the combination of location to get higher availability. The key thing to note out here is that the secret key that you get along with the account name is the same for both the endpoints. So if you get a shared access token, which is a token it's a pre-authenticated token, if you get this token, you can access your primary endpoint or the secondary endpoint with the same token. So you don't need two different tokens, or you don't need two different authentication signatures as such. It just works for the primary or the secondary the way it's been designed. So yeah, again, the same storage key works. And there's with respect to consistency, the thing to note is we are a strongly consistent system within the primary region. If you go to the secondary, it's eventual consistency. So reading from the primary, all writes have to go to the primary, but reading from the primary is always strongly consistent. We believe that it is easier for applications to develop when we provide a strongly consistent system as such for your primary region. And so that is something which is fundamental in our layer, where we make sure that if we have given a success for your write, it means it is persistent and you can read it. And again, like I said, applications can query the service stats to get the last sync time, and based on that can decide whether it wants to go to the secondary, whether it can withstand that eventual consistency on the secondary endpoint. And also, the analytics metrics that you get on your primary is also provided on the secondary, but it's in a separate, you have separate tables as such for both of those.